y'all doing? We're gonna be doing a quick sort, and okay, so quick sort. Well, let me give you a little bit of head start. Not head start, but what we're gonna be doing after that quick sort. I only have counting left, and then hash, and then after hash, I'll be doing a midterm view, and then we'll be done. Okay. So now for quick sort. How does quick sort work? Quick sort, basically you just want to know a couple things. The first thing you want to know is pivot. You choose a pivot point. The pivot point can either be the first one, it can be the last one, or it can be a median, which is you choose the last one, the first one, and whatever's in the middle. And then you take that, see which one is the median between those three, choose that as your pivot, or you choose a random pivot. And this is the best case, and I believe that's the one he's going to be focusing on. It's either this or first or last. Like, these are the three types he'll be testing you on, probably, from my guess. It does, the time complexity does differentiate with the pivot, so the pivot is very important when it comes to quicksort. We will be going over that once we, once we get a little bit through the code, we'll talk about the time complexity and space complexity. So here, let me mix these up because these don't look so mixed up. Let me put that here, put that there. Okay. Let's take the one, let's put this down here. And I'll switch these two. Okay, so after you choose your pivot point, what do you need to do? What you need to do after you choose your pivot point is you want to take everything other than the pivot point. So remember, we're going to choose our pivot point. We're going to start with we're going to use the rightmost as our pivot point. And so after we choose that, what we want is everything within this section right here is we want the middle of that, everything that is less than 10 to be to the left, everything that is more than 10 to be to the right. All right? Now that's the hard part of it. Besides that, everything else isn't too hard. So how do we do that? We're going to have these two pointers, left and right. The left pointer will point all the way to the left of that array, and the right pointer will point to all the way to the right besides the pivot point. So if your pivot point was the first one, let's say the 6 or like index 0, then your left will be one after the pivot point, and then your right will be all the way to the end, right? But we're choosing the one all the way to the right, so this is what it's supposed to look like. After you do this, what you want is you're going to have two loops. One loop will handle the left pointer. Excuse me. So how does that work? The way you do it is, the left pointer starts here, and like, is 10 less than or equals to 10? This is 10 is equals to 10. So we're going to hold on to it. Then you go, is the right pointer more than 10? If it's more than 10, you skip it. So since this is more than 10, we skip it. Then we go to 5. Is 5 less than 10? Or is 5 more than 10? No, it's not, so we don't skip it. Now that we have these two pointers in the right position, we swap whatever is at these pointers. Whoops. So the 5 will go here, and the 10 will go here. All right, so now let's code the first step, which is first, choose your pivot point. So int pivot equals the array, and we're going to choose the one at the end of the array. Then we're going to have two pointers. We're going to have our left pointer equals the array at the left, which is low index, right? And then we have our right pointer, which will be the at the high index, will be the array of the high index. Whoops, actually I messed that up. It's not supposed to be the number. We want the index because it's the pointer. So that's what it looks like. However, remember how we said we skipped the pivot? Since the pivot is the high index, right? The pivot is the high index. We're gonna skip it. So it's gonna do -1. If you're choosing your pivot to be the low index, so your low index will be here, then your all low index will be +1, and this will go away. So you're skipping, right? So keep that in mind. Now that we did this, we want the while loop. How does the while loop work? So let's keep going with this first implementation and see what we get to. So we know when the while loop will start to do this little, sorting, and when does it stop. So let's keep going. So what we have here, remember we just swapped, so left pointer again, is 5 less than 10? Yes, so we skip it. 4 less than 10? Yes, we skip it. Is 11 less than 10? No, we hold on to it. Then we do the right pointer. Is 1 less than 10? Yes, so we hold on to it. Then we will swap these two. Oh my god. Oh. This will go here. That will go here. And then again, is 15 less than 10? No, we hold on to it. Is 6 less than 10? Yes, so we're going to hold on to it. Then we're going to swap these two. Oh. Okay, then the left pointer will move on, and so will the right pointer. And in this scenario, we're going to be on the same position, and we're going to say, okay, so the left pointer will go, and it'll be like, is 14 less than or more than 10? Which, in this case, there's no point in checking this, because since both pointers are at the same place, we don't want to swap anything anymore, right? And so that's going to be our condition, is that if these pointers equal each other, or they cross each other, then we don't do the loop, we don't flip anything. We're going to say while the left pointer is less than or equals to the right pointer, keep going, right? If it's less than or equals, keep going. But as soon as they cross, stop. Okay? Now, the first loop handles the left pointer. So how do we handle the left pointer? We said if the array at the left pointer, so let's go back a couple steps here. Let's go here. So we're going to say, there you go. We're going to say if the left pointer less than or equals to 10. Well, not 10, to the pivot. Is this? So if it is, then the while loop should keep going and skip that number, right? So if is 4 less than 10? It is. So skip it, because it's in the right place, it's on the left side. And so that's what this says. It says if the left pointer is less than the pivot, then skip it. And so that's how it's going to go. And then here, and when the left pointer is less than the right pointer, less than or equals to the right pointer, then you want to also skip it. All right. Not skip it. You want to keep going until the left pointer becomes the same as the right pointer, or the left pointer becomes more than the right pointer. Then there's no point in incrementing the left pointer anymore. So if it is, however, if it is a less than the pivot, or the left pointer is still less than the right, then you want to keep incrementing it until you get the number that is more than 10. So left pointer plus plus. All right. Now the second loop is for the right pointer. So we're going to say right pointer. Is the right pointer more than the pivot? If the right pointer is more than pivot, remember this is not equals, because the equals ones, the left pointer will handle the equals ones. You don't want both of them handling it. So we're going to say, is the array of the right at the right pointer more than the pivot? If it is, keep going. So that's the while loop. So if this returns true, where the right pointer is more than the pivot, it should keep looping, as well as the left pointer being less than or equal to the right pointer. Then we're going to do right pointer minus minus, because remember the right pointer decrements and the left pointer increments. All right. Now once these two loops finish, now we have the left pointer being at a position that is holding a number more than. So this will hold a number more than 10, and the right pointer will hold a number less than 10. Now what we want to do is swap them. So how do we swap? We've been over swapping two numbers many times, but in Quicksort you'll use swap a couple times, so it's better to keep it in its own function. So we're going to do void swap. We're going to pass it the array. We're going to pass it one index, and then we're going to pass it the second index, and we want these two indices to swap. So how do you swap two indices? Oops. All you got to do is int temp equals the array at index 1. Then we're going to replace index 1 with array at index 2, right? And then we're going to have array at index 2 equals 10. All right, so now when we're here, remember, when left point is at 11 and the right point is at 1, we want to swap. We're going to pass it the array, and then we are going to be swapping the left point. So left pointer. Remember, the left pointer and right pointer hold indices. They're not actual pointers, they just hold indices. And then we have the right pointer. And these will get swapped. So do we always want to swap? What if this while loop exited not on this condition, but on this condition, where the left pointer and the right pointer are in the same position, or they have crossed each other? So if the left pointer, so here, let's go ahead. Can I go ahead? No. Oh. I can't. Let's say, thing is I gotta sort it so it works. Okay, let me sort it quickly. So remember, this is the point. We're gonna keep swapping all the way until this point, where the left pointer and the right pointer are in the same position. Now, if you swap this, you can, nothing will happen. But when you have it like this, where they cross, here swapping it, nothing will happen. But what if they cross like this? Then you don't want to swap these, because if you swap them, then it will be wrong. So we will only swap if the left pointer is less than the right pointer. That means they haven't crossed each other, right? Because if they cross each other, we don't want to swap them. And now this part is the partitioning part. That's the while loop. This while loop is the partitioning part. Where, sorry, no, the while loop is the sorting part. Now we're going to be doing the partitioning part. Once this is done, what's the next step? What we do is we want the pivot to go where the left pointer is. All right? So we want the pivot, so we want the left pointer to go away, and we want the pivot to come here. And now everything to the right of 10 is more than 10 or equals to 10. Everything to the left of 10 is less than 10. All right? And so now that that's complete, what we want to do is use our recursion. But remember, we haven't made in our code where we swap the pivot. So let's swap the pivot. So here we'll do swap. And what we want to swap the left pointer with the pivot. And the pivot is at the high index. Remember, the pivot is at the high index. So we'll swap these two. Why do I choose the left pointer and not the right? Because remember, so if I go back, if it looked like this, if I swap 10 with the right pointer, you see, if the right pointer was pointing to 14 and the left pointer was also pointing to 14, and you swap them, that's okay. But in the instance where they cross, you don't want to swap the right pointer because that would be the wrong place. The 6 will go to the right of 10. We wanted everything to the right of 10 to be more than 10. So that won't work. So if you're choosing the last element as your pivot, you want to swap it with the left pointer. If you're choosing the first element as your pivot, you want to swap it with the right pointer. Okay, so that's why I chose the left pointer to swap it with. So that's what it looks like. Now we're going to call quicksort twice. Why do we call quicksort twice? Remember, now everything to the left, so now 10 is in the right position. So now what we've got to do is we have to order the left side, do the same thing we just did, and do the same thing to the right side. So what we'll have, let's clean this out. So what we'll have is, again, we're going to have a pivot, which in our case, if we're splitting the left and right side, the pivot of this section will be 6, because the rightmost. So the right pointer will be the one before 6, and the left will be at the beginning. Then what we'll have is the left pointer is at 15, and the right pointer is going to be before 14, because 14 is the new pivot. Whoops. So I'm going to copy this. And now this is the recursive call, and this is also the divide and conquer. And so we're going to call it twice. And this is the important part, is you have to give it the right one. So if the first one handles this section, right, then what is the low index? The low index is just the low index, which is 0. But the high index is not, so the current high index was all the way here. Where's my pencil? Remember where 10 was? This is my current high index. So I don't want the new call for this array to be right here. I want it to be, obviously, the high index is this, within this small array. So what is this position? This position is one indice less than where the previous pivot is. Remember, this is the previous pivot is. So this is one less than the previous pivot. Where is the previous pivot? Remember, we switched it with the left pointer. So wherever the left pointer is, that's where the last pivot is. So my high indice for the left array is the left pointer minus 1. And for the right pointer, and for this section, the high indice is still the high index. That's the last one to the right. But the low index is to the right of the previous pivot. So the previous pivot was a pointer, was the left pointer, then it will be +1 because that's to the right of it. And that is really about it. Now, just like with any recursive case, you do need a base case, right? So for this one, what is going to be our base case? The base case here, if we keep going, so here, let's do this left side. So how do we do it? So we know that 14 is the pivot, everything, so left, everything is to less than 14. So is 15 less than 14? No, we hold on to it. Is 17 less than 14? No, so we skip it. Is 10 less than 14? Yes, we hold on to it. So then we swap these two. Right? Then what's going to happen here is the left pointer will go here, and the right pointer will move like so. And so here it's going to be like, okay, is the left pointer less than 14? Yes. We skip it, right? So it's going to go 1. And now it's going to exit since the left pointer is less than the right pointer. So the left pointer won't move anymore. Now the right pointer is going to go like, okay, is the right pointer more than the pivot? No. So this is going to loop. Also, is the left pointer less than the right pointer? No. So the loop will actually exit. And so then, is left pointer less than right pointer? No. So we don't swap these anymore. Then this happens where we swap the 14 with the left pointer. So these two will swap just like this, right? And so again, this will happen one more time. This is the old pivot, so the new array, the right pointer is going to be 1 less than the pivot. So remember, this is the array. 10 and 11 is our small array. Remember, the right pointer will be 1 less than the current pivot, and the left pointer will just be the beginning of that little array. So now, when this runs, right, so this will get called, this will run, the right pointer is going to be the high index minus 1, which is the 10, and the left pointer is going to be the low index, which is also the 10. Obviously, we're going to have the same thing happening here to this right side, but I'm going to skip that. So then the while loop, is the left pointer less than or equal to the right pointer? It's equals to, so this will run. Then it's going to say, okay, is the left pointer less than or equal to the pivot? The pivot is 11. This will be true. Okay, is the left pointer less than or equal to the right pointer? This is also true. So left pointer plus plus. Left pointer plus plus. All right, and then what's going to happen here? The right pointer, is it more than the pivot? Is 10 more than the pivot? No. So this will be false, therefore this won't run. Is the left pointer less than the right pointer? No. So these will never swap. Then I'm going to swap the high index 11 with the left pointer. So it's going to swap itself, so nothing will change here. All right. Then it will call quicksort, passing it a low index, and our low index is where our p is, which is just 0. So we're going to pass it 0 right here. And then the the left pointer, whatever it's at, minus 1. So that's what we're passing. We're passing the same indice, right? And so what's going to happen here, these two, if they're equal to each other, or if the low index is more than the high index, then we have reached the sort. We don't want to run this anymore. So that's going to be our base case, is that if the low index is more than or equal to the high index, then return. Don't do anything because there's nothing to sort. You're trying to sort yourself. All right, and so that is about it for this part. Let's run it and see if we have any mistakes. 1, 1, 1, 4, 14, 21, 26, 30, 38, and 47. So that is right here, if you could see it. Hope it's big enough. Let's run it one more time. Oh, when we ran it here, we got a out of bound error for length 10. 33, 31, why? Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. By the length, I have preset it to size. Size is always 10. So let's see if I run it. Okay. Huh, why did I get that error? Oh, I got the error again. Index -1, out of bounds for length 10. That's kind of odd. What if I don't make these equal? Let me see, maybe this is the cause. I haven't run into this error before. Well, you see, when I break this, it doesn't sort it the right way anymore. So let's say these ones. Random array. Oh, this doesn't even work properly. Oh, that is odd. Let me look into it and get back to y'all. I'm not sure why it breaks, so we'll see and I'll get back. The issue was these, we were doing this first. So this was here and this was here. And the problem with that is that when I do array at the right pointer, if the right pointer, let's say, goes past, points to like a negative or something, and I try, like, let's say the right pointer is not at index 0, it's at index -1, and I try to do it, it gives me an error. So first, you basically, all we did was switch them. First, we make sure the pointers are not across each other before we try to check this. And that was the only issue there was. So I just flipped this and I flipped that. Just keep that in mind, that first you want to check the pointers before you check their values, which kind of makes sense now that I'm thinking about it. Because if the pointers are crossed, the while loop will never run. So there's not even a point to check their values, which kind of makes sense. All right, not kind of, it does make sense. Now a couple of things I'm going to show you guys on how to customize it. So first, let's run it. This gives us ascending order. If you want descending order, all you gotta do is switch these to the opposite sign. So whatever the opposite sign is, switch it, and you see when you run it, this will now be descending order. All right. Now another thing is, what if you want to switch it such that you want to start using the low index? So for the low index, all you have to do is the pivot is going to be the low index, obviously. Now the low index, remember, we want to skip the pivot point. So this is going to be +1. We don't need this anymore, right? Now what's the other thing you got to change? Here, when we want to swap, we're not swapping the left pointer with the high index. We're swapping the low index, which is the pivot, with the right pointer, right? And here, instead of a left pointer, we pass in right pointer. And this will now make it use the first index as the pivot point. All right. Now I'm gonna put it back to how it was, using the high index as the pivot point. All right. And now I'm gonna show you how to do a random. The reason for, actually, after we finish, we'll talk about time complexity. So now, how do you do random? For random, all you gotta do is, instead of choosing the pivot at this location, first you want to get a random pivot. So int random pivot index equals new random dot next int. And the way next int works is, you'll give it a number, and it will give you a random number between 0 and the number you gave it. All right, so if let's assume we're doing this section right here. Let's assume we're doing this section right here. So what I'm trying to do is get a number that is random between how many? This is 0, 1, 2, 3, 4, 5, between NDC 6 and 6, 7, 8, 9. So NDC 9. That's what I'm trying to get in between. So I want a number from between, random between 6 and 9. So since I know this gives me a number between 0 and whatever number I give it, what if I do, so here, first actually, let's do this section. I feel like that'll be easier to understand. So 0, 1, 2, 3. I want the number between 0 and 3. This random will give you between 0 inclusive and 3 exclusive. So if I give it 3, this will give me between 0 and 2, being 2 inclusive. So it can either be 0, it can be 1, it can be 2, but it will never be 3. So we'll have to pass an extra 1. So if I want a number between 0 and 3, I'm going to have a number between high index minus low index, and then plus 1. So whatever the difference, so you see what I'm going to say is high index 3 minus low, which is 0, so now it's still 3, plus 1, which is 4, because 4 is excluded. So now same thing here. If I'm doing this section, what I'll be doing is high, which is 9, minus 6, that will be, 3, plus 1, 4. And so it will give me either 0, 1, 2, or 3 for this section. Now, obviously, I want 6 and 9. So what do? What if I do plus the low index? So you see here, when I get a 3 plus 6, that will give me a 9. If they give me a 2 plus 6, that will be 8. So now the numbers are between this and this inclusive. Now, I only got the index. I still gotta use that as my pivot point, right? So how do I use that as my pivot point? Instead of doing int pivot being the array at the high index, first I want to swap, because remember, I choose a random number as the pivot, then I want to put it at the end of my array, all the way at the end, and then use it as the pivot. So that's what I'm going to do. Then I'm going to say swap. I'm going to give it the array. I'm going to give it the random pivot index, and I'm going to give it the high index. So now whatever random out of this whole array, maybe it's a 4, maybe it's a 1, whatever I chose, I'm going to move it all the way to the end, and then just do the same thing I've been doing all before. Make the pivot the right one, which is going to be the 1, because the 1 moved there, and then use that. So here, let's run it and see if we have any issues. And that works. 30, 31, 38, 43, and that works. And so this is more fast. Now, why is this more fast? Let me tell you a couple things. We're going to do space complexity and time complexity. For time complexity, the time complexity of a quick is the same as a merge, which is O of n log n. All right, so this is, here, let's do it. This is going to be your O of n squared, and this is your O of n log n. All right, so as you can see, this is faster. Now for quick, that's the time complexity. However, there is a worst case scenario of, remember here when 1 was the last one? So here, let's do this. I shall keep the pointer, and I'll show you guys why this worst case scenario happens. So if you always choose the right indice, sometimes there's a possibility you'll always get the minimum value or the maximum value within this small array. And so here, when I keep checking, is this less than 1? No. Is this less than, if this is less than 1, you skip it. If it's more than 1, you keep it. Then I go to the right. Is this less than 1? If it is, then I keep it. But if it's more than, I skip it, right? So is this? No. Is this? No. Is this? No. And see, now all I do is I swap this with this. And you see, I did so many checks just to do one swap. And when your array grows, that gives you a very bad time complexity of, believe it or not, will give you a time complexity of O(n) squared, which is the same as this one. And so that's why we don't choose. In the worst case scenario, the last element and the first element will give you a O(n) squared. And so in the best case, it gives you n log n. And to get the best case, we use the random or the median. Random or median gives you the best case. Now we're going to do space complexity. For space complexity, if you're using recursion, with recursion, so with recursion, you get a O of log n and without it, you'll get O of n, which is linear. So you either get linear if you don't use recursion, because with recursion, you're doing an in-place sorting. Remember, we do like mini arrays, like we do split them, but it's in place, like we use the actual array. So this is what it looks like for log n when you're using recursion. But when you don't use recursion, it will give you linear. However, we haven't learned, or he hasn't been even over doing quicksort without recursion. So you guys don't worry about it. You just want to know the time complexity of it. All right. So if he asks you, which I think he would, if he asks you if quicksort, what is the benefit of quicksort over merge? Quicksort can be better than merge when it comes to time complexity. So if space is an issue, then you want to use quicksort. All right, but if space is not an issue, it doesn't really matter which one you use. It just depends on your scenario. Okay, so that wraps up quicksort recursion. Well, no, quicksort. All right, guys, have a great night.